Welcome to my 90-day SAT prep series. Today is day 83 out of 90. You took your practice test on day 81 and reviewed your practice test yesterday. So hopefully that practice test went well. Hopefully you're feeling very prepared going to your SAT, which hopefully you have scheduled on day 91. Okay, so today what we're going to do is we're going to play a game with the math section. So we're going to start with the math no calculator section, and then we'll do the math with calculator section. So it's kind of a game in that what I'm going to do is I'm going to select a few problems from each section. I'm going to go there, I'm going to tell you the problem, and then we're going to do what I call do you see what I see. So I'll go ahead and give you right around 45 seconds or 30 seconds or a minute to solve a problem, and then at the end what I'm going to do is I'll go through and I'll show you what I saw in that problem that would help me get to that correct answer efficiently. So it could be something as simple as where I start, as far as which answer choices I can get rid of the soonest in order to get to my correct answer using process of elimination, or it could be something where I see a setup such as a stacked equation set or anything like that. So really implementing a lot of the tips and tricks I talked about over the last 90 days and seeing if you can sort of see things the way I see them that has allowed me to score perfectly on the math section of back-to-back SATs. So with that, let's go ahead and get started with the math no calculator section. This will be from practice test number 9. Okay, you can find the practice test linked in the description if you would like. To start, we're going to start out with question 2. So I'm going to give you 30 seconds for question 2 because it should be a pretty quick one. And at the end of those 30 seconds, I'll go ahead and show you what I see in question 2 that helps me solve it quickly. So your 30 seconds starts now. Okay, your 30 seconds is now up. So what I'm going to do here to show you how I can solve this one quickly is when I have multiple choice questions like this on the math section, and I have something like this where I have to distribute something or anything like that, anytime I see that I can solve for one variable and get to my answer faster, that's what I'm going to do. So what jumps out immediately to me, right, is I would be looking at which term is different in A through D. Now in this case, there's not one term that is different in every answer A through D, but what I do see is I see 5x squared is the same in A, B, and D. So I don't want to start there because it's probably going to end up having 5x squared, and then I still have to solve for my x term. But if I look at my x term, I see I have minus 5x plus 5x, and then and then 5x here, and then I have no x term here. Okay, so what I'm seeing then is I see I have obviously two terms where I have 5x, right, in options B and option C, and then I have one term where I have no x term, and then one where I have negative 5x. So what I see then is I have three possible options as to what my x term can be. So if I solve for my x term first, it's quite likely I can go ahead and solve for my answer. So that's what I'm going to do here. I'm not even going to worry about my x squared term to start. I'm just going to move this 2 over to this negative x. That's going to give me minus 2x. And then I'll have plus 3 times negative x, which will be minus 3x. And that's going to give me negative 5x. I see my answer then is going to be A, and I don't even have to worry about my x squared term. So the thing that you should be looking for when you deal with questions like this on the multiple choice is which term can I solve for in order to get my correct answer the fastest. In this case, solving for your x squared term isn't going to help you because then you just have to solve for your x term as well. Okay, so always be looking for the variable you can use to solve your answer the fastest and only solve for that one if you can only solve for that one and get to your correct answer. So in this case, answer there is going to be A. Let's go and find another one where I can show you a sort of test taking strategy that should help you out. 4 looks like it'd be a good one. I also like 3. We're going to go ahead and do 3 here. Okay, so 3 is not necessarily a big old tip here. It's just understanding how to manipulate variables. So with that, let's go and start with 3. I'll give you 30 seconds for 3, starting in 3, 2, 1. Okay, your 30 seconds is now up. So the thing that you should be looking at right away when you see that you have this equation here is obviously it's not in slope-intercept form. So what you want to do then is get it in slope-intercept form since you're obviously asked about your slope and your intercepts. So you see that, you just want to manipulate it, get it in slope-intercept form. So to do that, you're going to add 3x to each side. It'll cancel right here. Now you're going to have 3x minus 4 over there. You divide each side by 2 to get y. And you're going to have 3 over 2x, which tells you it's going to be a positive slope, minus 4 over 2, which tells you it's going to be a negative y-intercept. Thus, your answer there is going to be D. Okay, so key things there. If you're given an equation that isn't in slope-intercept form, right, and you're asked about slopes and intercepts, it can help to go ahead and convert it to slope-intercept form right away. That way you can just immediately tell if it's positive, negative, as far as your intercepts and your slopes. So that one right there is kind of a minor tip. We're going to get into some with some better tips there. I just wanted to review that one because I know that some people get tripped up when they have equations that aren't in slope-intercept form. So to convert it, just get your x to the side with your constant or your intercept, and then get your y alone. All right, moving on. I like number 4 here because it's a word problem dealing with equations, so we're going to go ahead and do this one. So I'll go ahead and give you 30 seconds for this one as well, starting in 3, 2, 1. Okay, your 30 seconds is now up. So the key thing with number 4, I'll go ahead and point it out to you. So when you're dealing with a word problem, always be looking once again, like I talked about before, for the variable that can get you your answer. So right away, you should see that you have a 15, a 335 over 8, 335 over 15, and a plus 8 as your intercepts. Obviously, all your intercepts are different, so we don't need to worry about our slope. Let's just focus on the intercept because that'll get us our answer. The front of a roller coaster at the bottom of a hill and is 15 feet above the ground. Okay, so I know my height, its intercept's going to be 15 feet above the ground. If the front of the roller coaster car rises at a constant rate of 8 feet per second, which of the following gives the height h in feet of the front of the roller coaster car s seconds after it starts up the hill? Well, its intercept is going to be where s is 0, okay, because that's when the time starts. We know that at 0 seconds, it's 15 feet above the ground. Thus, our answer there is going to be answer choice A. Okay, so key thing there, notice how I didn't worry about slope since we saw that we had repeats of slope, but we had no repeat of our intercept. So once again, similar to the tip that we had for number 2 and then also with the word problem, just making sure that we're keeping track of important information there. All right, moving on, let's go and find another one that we can review a tip or trick on. So 4, the key thing you should have saw that I saw is not worrying about slope, worrying about intercept, since that would get us our answer there. All right, moving on. Okay, I like number 6. I also like number 5. Let me see if number 7. Okay, number 7 is going to be a simple one, so we're going to skip that one. We'll do 5 and 6 here. So let's go and start with 5. All right, number 5. Okay, it's got a word problem with an equation. I like doing these ones because I think that they're good. They keep the logic and reasoning going through your mind as well. So number 5, I'll go ahead and give you 30 seconds starting now. Okay, your 30 seconds is now up. All right, so we've got our equation C equals 75H plus 125. We read through, we have the equation gives the amount C in dollars and electrician charges for a job that takes H hours. Ms. Sanchez and Mr. Rollins each hired the electrician. The electrician worked 2 hours longer on Ms. Sanchez's job than Mr. Rollins. How much more did the electrician charge Ms. Sanchez than Mr. Rollins? So we know we have a difference of 2 as H. So since it's a 2-hour difference, we multiply that 2 by 75 to get our difference in cost as $150. Okay, this one here. Key thing with word problems, underlining things as we go through. Not really anything big as far as a tip or a trick. Just wanted you to understand how to do that one. That's why I included it there. Now let's go ahead and find one where we have more of a tip or trick. All right, so we've got 6. That's going to be pretty much a basic geometry problem. Solving for the length A, B, C, things like that. I'll just go ahead and solve this one on my own. I won't take you through the 30 seconds. I'll just go ahead and do this one. All right, so we have the circle above has center O. The length of arc ADC is 5 pi. So we have ADC is 5 pi. What is the length of arc ABC? All right, well, we're told x is 100. Okay, and we're told that we have 5 pi there. So we know that that 100 as our angle there over the 360-degree angle has to be equal to our 5 pi. Okay, our 5 pi over the total number of pi in the circle, okay, which we know is going to be equal to our circumference, right? So we have our circumference would be here. Okay, so we can go ahead and solve for that circumference then using those ratios. Now, one thing I want to note here is that when we set up this ratio, if we ever see that we have the variable that we want to solve for, in this case our circumference on the bottom, we go ahead and flip it, right? So if we initially wrote it like that, we flip it to go up top. Now, why do we do that? Well, we flip our numbers like that so it's easier to solve. Because by flipping it like that, we can multiply by 5 pi to each side, multiply each side by 5 pi, right? We go ahead and simplify here. We know that 5 goes into 100. We have a 1 there, and we have a 20 here. Okay, we can go ahead and cancel these zeros as well. So now we have 1 times 36 times pi, so 36 pi over 2. We know that's going to equal 18 pi, which will equal our circumference. Now we just go ahead and subtract 5 pi from our circumference. Okay, so we have 18 pi. We go ahead and subtract that 5 pi. We're going to end up with 13 pi then as the angle or the length of arc ABC. Okay, so the tip and trick here that I actually forgot to include, that I actually should have had you do this one on your own to see if you caught this. That would have been helpful to see if you could catch this. But anytime you're given a setup where you have ratios like this, and the variable you want to solve for, in this case it is C, is on the bottom, you flip your ratio. Okay, so I should have initially wrote it with C up top. Obviously, I was kind of just writing it as I looked through the problem, but anytime that you notice that you have the variable you want to solve for on the bottom, in this case it was C on the bottom, you go ahead and flip it. The reason that you flip it on each side is because then you have C up top and it takes less steps to solve, right? You just multiply each side then by the bottom one, and you automatically are given what C is equal to. Okay, so that's the key thing there. Answer there is going to be B for number 6. All right, so key thing there with ratios, make sure the variable you want to solve for is on top, okay, because it gives you less steps, helps you solve it faster. Number 7 is going to be really easy, so I don't want to waste time on that one. Looking at 8, that's also going to be one that's not really dealing with any tips or tricks. Looking at 10, once again, not really one that deals with that many tips or tricks. 9, I like this one, graphs with how many solutions the system of equations have. Okay, I like this one. This one's not really necessarily going to have a ton of tips or tricks, but you should be able to solve it fast, and I want to make sure you can. So I'm going to go ahead and give you 20 seconds to solve this one starting now. Okay, your 20 seconds is now up, so you should have been able to solve this one in 20 seconds because it's pretty simple. So we see we're asked for what or how many solutions the system of equations has above. That's going to be where all 3 lines intersect. We see that only occurs once. So our answer there would be 1, which is going to be B for number 9. Key thing here, understanding that when you're asked for the solutions of a system, right, and you have 3 different things, it has to be only where all 3 intersect. Okay, because the reason I included this is because sometimes you get so used to only having 2 equations and finding where 2 equations intersect. If you're asked for 3, it's where all 3 intersect, then it's going to be a solution. Okay, in this case that only happens once, which is going to be right here. Thus our answer there is going to be B for number 9. All right, moving on, let's go and find another one. Okay, you should have been able to solve that one fairly quickly since it was fairly simple. Okay, looking at 11, 11's not too tough. 12, once again, 12 not too bad either. Okay, 13, I like this one again, dealing with graphs. I like graph ones as far as review things before the test because I want you to be able to solve them really quickly, because graph questions you should be able to solve really quickly. All right, so 13, I'll go ahead and give you 30 seconds on this one, starting in 3, 2, 1. Okay, your 30 seconds is now up. So you should have been able to solve this one in 30 seconds by recognizing that we have the vertex formula here. Okay, so in our vertex formula, we see that we all have +1 as our y coordinate for our vertex, which is obviously true. Next thing we see is that we have our x coordinate of our vertex, x at 3. So we must have x minus 3. We see we have x plus 3 in B, B is wrong, x plus 3 in D, D is wrong. Now we're between A and C. We see that if we go 1 to our right, we go up by 4, because we go from 1 to 5. So we go up by 4. Thus, since we have a squared term, we're going to have this 4 be out in front here. Okay, we can't have a 1 there, which is what it is in C. So C is wrong. Our answer there would be A, because we have to multiply that increase in x of 1, which 1 squared is 1, by 4. Okay, 1 squared is 1. Thus, 1 times 4 gives us that increase in 4. Answer's A. So key thing there, recognizing the vertex formula, right? We see that we're going to have our vertex at 3 and 1. Thus, we are going to have an x minus 3, allows us to get rid of 2 answer choices right off the bat. Then we look at how we increase going 1 to each side, right? Another thing that you'd be looking at in 13 is if you could get rid of an answer choice because it opens down, okay, in your equation, then that would help as well. In this case, the graph obviously opens up, so any equation that would open down would be incorrect there as well. So that's just another thing you could look for on that one. Okay, 14, I like this one. We have not, this one's kind of a rarity or an oddity on the SAT math section, but it could show up, so I do want to cover it because I don't know if we've covered it that much in the 90 days. So I actually really am glad that this one showed up. Okay, so 14, I'm going to go ahead and give you 30 seconds to do this one starting now. Okay, I believe that that was 30 seconds. All right, so let's go ahead and run through how to solve these inequalities problems with graphing, okay? So inequalities problems with graphings, they can show up on the SAT math section. They don't necessarily show up a ton, but let's run through them anyway. So in which of the following does the shaded region represent the solution set in the XY plane to the system of inequalities above? Okay, key things here is I generally like to use the slope-intercept form when I'm dealing with graphing inequalities like this. So what I'm going to look at is I see I have y has to be greater than x plus 2. So I'm going to put this equation in blue, right? I'll put it in blue so you know which one I'm talking about. All right, so we have y must be greater than or equal to x plus 2. So I draw my graph, I've got my equation, I got my intercept at 2 here. We know we're increasing by 1 since our slope is x, which is just 1. Okay, so we're going like this. We know that y has to be greater than that. So we could go ahead and shade in all this area over here because we know y has got to be greater than that. All right, next thing that we've got, we'll go ahead and use green for our other one. Okay, so this other equation, we're going to use green. So we have 2x plus 3y must be less than or equal to 6. So what I'm going to do here is I'm going to go ahead and rewrite this in slope-intercept form since that'll help me solve. So I got 2x plus 3y has to be less than or equal to 6. I go ahead and subtract that 2x from each side. Subtract 2x from each side. Go ahead and divide each side by 3, isolate y. So now we're going to have 6 over 3, which we know will have that same intercept of 2. And then we'll have minus 2/3 x. All right, so we can go ahead and graph that one. We have the same intercept. We know that we're going down and a slope of negative 2/3. So it's going to look like this. Now, what we also know is we know that our solution has to be less than, right? We see y has to be less than that. So our solution where blue and green is in this graph is going to be right here. Thus, our solution then, when we go ahead and get rid of that, we know our solution, I'll put in black here. Okay, our solution is going to be this shaded region here because it satisfies both of those inequalities. Okay, so we look at the graph that matches that. We see D doesn't, we see C doesn't, we see A doesn't, we see B does. B will be our correct answer there. All right, so the key things dealing with number 14, when you're graphing system of inequalities problems, usually it's going to be helpful if you put them both in slope-intercept form. Okay, that's something that's going to prevent you from making a simple mistake or misinterpreting something. So I recommend putting them both in slope-intercept form. That's what I would see when I see question 14. The other thing that you want to make sure is that you're paying attention to where the sign is pointing. Okay, so pay attention to if it's less than or greater than or equal to. You've got to pay attention to that sign. If you misinterpret that sign or you misread it or you only glance at it and get it wrong, you got to make sure you're paying close attention to where that sign is pointing. Those are the key things when dealing with questions like these. And then after that, just making sure that you're graphing it, right? All right, so at this point, we can go ahead and move on. Let's go ahead and take a look at 15. Do I want to solve? Yes, I do want to solve 15. So 15 is important because it's going to be one where you have to check your answer. Okay, and I like these ones. I guess I just kind of gave it away, but I'll go ahead and give you 20 seconds to solve this one. So your 20 seconds starts in 3, 2, 1. Okay, 20 seconds is now up. So what you're going to do here is you're going to want to get rid of that square root. You're going to get rid of that square root by squaring it. Now you got x plus 2. Obviously, you got to square each side. X plus 2 is going to equal negative x times negative x, which you know is going to give you positive x squared. At that point, what you could do is you can go ahead and set it equal to 0, or another strategy you can use, and the strategy that I would use is I would see that I've got a negative 1 and a 2, and I see that I have that in all of them. So in this case, what I would just do is I just plug and chug. So you can do this way, go through and solve that way by setting it equal to 0, finding your roots and all that, or you can just go plug and chug. Either way, it's going to take you right around the same amount of time, so it's up to you. If you want to plug and chug, you'd see you have negative 1 plus 2, that's going to give you square root of 1, thus 1, and then does that equal negative 1? Yes, it does, because negative 1 is going to give you positive 1. So you know negative 1 can be a correct answer. Now, what about 2? Well, let's plug in 2. 2 plus 2 is going to give us 4. Square root 4 is going to give us 2. Does 2 equal negative 2? It does not. Thus, 2 is going to be incorrect. So we look at our options then. We see that B would be our correct answer. Okay, so your options there, you can plug and chug for this one. The reason I say it's okay to plug and chug on this one in particular is just because there's only two numbers you have to plug and chug, and you also see that your equation's pretty small. Okay, so if you see an equation that's pretty small like this, you see you only have two numbers that you have to plug and chug, then I'm perfectly fine if you want to do that. In cases where this equation up here is larger or longer, I don't recommend plugging and chugging, especially if you have three or more numbers that you have to check, because that's going to end up taking a long time. So most of the time, I don't recommend plugging and chugging, but in situations like this where you do have small math to do, right? You only have to deal with one square root, an x there, a 2 there, and a negative x there, and you only have two numbers to chug, plug and chug. I'm okay with if you want to do it that way. Otherwise, if you were to do it this way, I'll go ahead and show you how this is going to work. Okay, you'll have x squared, you want to subtract x, you'll subtract -2, or subtract 2 from each side. You're going to end up with x squared minus x minus 2 equal to 0. You'd factor it out, you'd get x minus 2 and times x plus 1, right? You'd see that you'd have x equals 2 as a factor, and you'd see you have x equals -1 as a factor. You'd go ahead and check them, and then you'd end up seeing that you have your answer as B, right? So either way that you want to do it, I'm okay with either one. The benefits to doing it this way, right here that I'm boxing and not just plugging and chugging, is that if neither -1, 2, or -1 or 2 worked, you would have to then go through and you would have to factor and check it to see if there was indeed no solutions to the given equation, because it's possible that a solution could have been 3 or something, right? So you would then have to go through and you would have to do it this way. So that's why I'm fine either way, because by plugging and chugging, the odds of you getting one of these answers A, B, or C as your answer is pretty high by plugging and chugging. So the odds that you would then after that have to go through and do this are kind of low. So once again, okay plugging and chugging there. Also, if you wanted to just do it this way, I'm okay with that as well. So either method you wanted to use there is fine. Okay, so obviously that one took me a while to explain just because I wanted to show both ways and explain the differences, the pros, cons to each method, but hopefully you understand how to do that one now. Hopefully you have a strategy in mind for as how you're going to handle that. It might be helpful to go ahead and make a choice as to whether or not, if you see that problem on the SAT, you're going to plug and chug or do this method on the right, because then you don't have to decide when you're doing it because you already know what your answer is going to be and you already know the method you're going to choose. So it could be helpful to go ahead and make a decision there, but it's totally your decision on that one. All right, moving on, let's find some other ones that I want to review. I'm definitely going to want to review 18. I can already tell on that one. I don't think I want to, yes, I do want to review 17 actually. Not because there's a trick to it, but just because I got to stop giving away answers. Yeah, 17 I definitely want to review, not because there's a trick to it, just because I want you to make sure that you're looking out for something. 16, I don't want to review that one. That one's just basic. 18, I do want to review that. 19, I want to review that one. 20, I'm going to want to review that one as well. So we're just going to go ahead and review 17, 18, 19, and 20 here. So we'll go ahead and start with 17. Okay, 17, I'm going to give you 20 seconds on this one because it should be pretty quick. Your 20 seconds starts now. Okay, your 20 seconds is now up. Hopefully you got your answer. So key things here, we're just going to go ahead and subtract 2 for each side. Keep in mind we're asked for the value of 2x plus 1. That's why I wanted to do this problem, is because I want you to pay attention to what you're asked to answer with. So in this case, we got to solve for x first. We go ahead and do that. We're going to get 2 equals 4x. Divide each side by 4. Divide each side by 4. We're going to get x equals 2 over 4, which we know is 1/2. Then we do 2 times 1/2. Plus 1, we know that that's going to give us 1 plus 1. Our answer there is going to be 2 for number 17. Okay, the reason I wanted to do this one is because I want you to make sure you're watching out for what you're asked to answer with. You're asked to answer with the value of 2x plus 1. Okay, now another way you could have done this is you could have initially looked at this. You could have said, okay, I'm asked to answer with 2x plus 1. Well, what's half of 4x plus 2? Half of 4x plus 2 is 2x plus 1, which I know must equal half of 4, which must equal 2. Okay, so if you were able to recognize this ratio right away, which would be really, really good if you did, then you're going to go ahead and find your answer as 2 really fast. Now, if you didn't, it's okay if you had to go through and solve for x, because you saw you're still able to do that one in right around 20 seconds, 15 seconds. So either way there, you know, sometimes you're going to recognize the ratio, sometimes you aren't, right? It's just going to be something that's just going to happen. It's going to click or it's not. Okay, so if it doesn't click and you have to go through and solve x first, that's perfectly fine, especially with a problem like this, because it's not going to take you that long. If you're able to recognize the ratio right away, boom, that's incredible, right? You're going to be able to go ahead and solve your answer in right around 5 seconds, maybe 7 seconds, right? So either way, only a difference of right around 8 or 10 seconds there. So not a huge deal. Don't be upset if you didn't recognize the ratio. You're still going to get the problem right and you're going to solve it really quick anyways. But key thing here is understanding you want to pay close attention to what you're asked to answer with. Okay, so those are the two things there, looking for ratios and then also paying attention to what you're asked to answer with. That's why I chose that one. All right, 18. I like this one because it's not just a linear graph or a simple parabola like we're used to seeing. Right? I want you to see graphs besides those as well before you take your SAT. Okay, the figure above shows the complete graph of the function f in the xy plane. The function g not shown is defined by g of x equals f of x plus 6. What is the maximum value of the function g? I'll go ahead and give you 30 seconds on this one because it could be a little tricky. Okay, your 30 seconds is now up. Hopefully it didn't trip you up. It's really not that tough, okay? When we look at this, we see we're asked for the maximum value of the function g. Maximum value of the function g means we're going to take the maximum value of the function f of x, which is shown in our graph, and we're going to add 6 to it, okay? Because it's f of x plus 6. We see our maximum value of f of x is going to be at 2. We add 2 to 6, and we're going to get 8 as our answer there. Okay, key things here, just understanding your graphs, understanding how to manipulate, not even manipulate variables, really just understanding how to interpret a graph, right? This one's not too difficult. Kind of surprised it's at 18, right? I'd more expect to see that one at 16 or 17, given its ease with which you can solve it. But key things here, just understand if you're asked to do something with g of x and f of x, just understand not to panic, right? Obviously, there's two equations there, but it's pretty simple most of the time. So stay calm if you see two equations or two graphs like that, you'll be okay. All right, moving on, we got question 19. Question 19, I'm going to go ahead and give you 20 seconds on this one because you should be able to solve this one fairly quickly as well. So 20 seconds starting in 3, 2, 1. Okay, your time is now up. Key thing you should see right away is you have a right triangle, right angle Q. Let's go ahead and quick draw this out. We'll put Q right here, right? We'll put P here, we'll put R there, we'll put P here, right? We know the sine of R is 4/5, thus our hypotenuse is going to be 5. Sine is going to be opposite of R, then it's going to be 4. We see we have a 3, 4, 5 triangle. We're asked for the tangent of P. We know tangent is going to be opposite over adjacent. We see our opposite's 3, we see our adjacent is 4, thus our answer there is going to be 3/4. Okay, key things here that I wanted you to see that I saw. Immediately when I saw I have sine R is 4/5, I was thinking 3, 4, 5 triangle, okay? So my hypotenuse would be 5, both my legs would be 3, 4. That's immediately what I was seeing there, okay? Now the other thing that I was seeing right away is I was looking at my sine, right? So I saw that I had my right angle at Q. I saw I was asked for the tangent of P. Thus, all I had to do is think, okay, my hypotenuse will be 5. I'm asked for my tangent. I know that that's going to be my opposite over my adjacent. I know my opposite is going to have to be that 3, and my adjacent would have to be that 4, okay? So key things there, just understanding that 3, 4, 5 triangle. The other triangle that you should know is going to be that 5, 12, and 13 triangle, okay? The 5, 12, 13 triangle. If you know the 5, 12, 13 triangle and you know the 3, 4, 5 triangle, that's going to help you out significantly on the SAT math section. All right, last problem for today's math no calculator section review for the do you see what I see. I'll go ahead and give you 30 seconds on this one. So your 30 seconds starts now. Okay, I believe that your 30 seconds is now up. So we see that our question says the graph of the linear function f is shown in the xy plane above. The graph of the linear function g is perpendicular to the graph of f and passes through the point 1, 3. What is the value of g of 0? We know g of 0 is going to be its y-intercept because that's where x is 0. So what I know is I have a perpendicular graph. I see my slope of f of x is going to be -2. Thus, my perpendicular graph is going to be the reciprocal and then the opposite sign, right? So it's going to be a positive sign then, and then we flip our fraction to 1/2. So our slope is going to be positive 1/2. I see my coordinate or my point at x is going to be 1, and I see at 1 I'd be at 3. Okay, so I can go and plot that. I'll plot it in blue so that way you know the difference. Okay, this is for my perpendicular line, g of x. Now, I know if my slope is positive 1/2, that I'd have to go back by 1/2 or down by 1/2 if I go left from 1 to 0. Thus, I see my intercept will be at 2.5. So my answer there is going to be 2.5. So you could write 2.5, you could also write 5 over 2. Either of those ones would be correct. All right, so that takes us through our math no calculator section review and the do you see what I see. Let's go ahead and cover some questions on the math with calculator section. All right, let's get started with the math with calculator section. Once again, we'll be doing do you see what I see with most of these problems, so I'll give you 30 seconds or so to solve the problem. After that, I'll go through and show you what I saw that made me want to do the problem, why I wanted to review it, as well as tips, tricks, strategies, and things like that with the problem. So let's go ahead and take a look. I like number 3 right off the bat. That's one I see that I want to do. Okay, so let's go ahead and tackle 3. I'm going to give you 25 seconds to do this one starting now. Okay, your 25 seconds is now up. So here's what I saw that made me want to do this one. I saw I had 2n here, and I saw I had 2n minus 1 as what I need my answer. Once again, pay attention to what you're asked to answer with. In this case, that's 2n minus 1. So to solve for 2n, I multiply each side by 5 to get rid of this 5. 5 times 10 we know is going to give me 50. I have 2n then equals 50. Then I just do 50 minus 1 gives me 49 as my answer. So I know my answer is going to be B for number 3. Okay, so the reason I wanted to review this one. Anytime that I see I'm asked for the value of something at the end, in this case 2n, and I see that I have 2n, I don't solve for n because I already have the 2n that I need. Okay, if I was to solve for n, I just got to multiply it by 2 again. So I'd be dividing it by 2 just to multiply by 2 again. That's wasted time. So pay attention to what you're asked to answer with. Make sure if you're asked to solve for something such as 2n or 3x or whatever, and you have that, don't oversolve. Okay, only solve to the necessary point. All right, so answer there is going to be B. Let's go and find another one that I want to talk about. Okay, 1 is too simple. I'm not going to talk about that one. 2 is pretty simple as well. Looking at number 4, I'm going to talk about number 4. I kind of covered it a little bit in the math no calculator section, so I'm only going to give you about 15 seconds with this one starting now. All right, your 15 seconds is up. Obviously, 15 seconds is really quick, right? I only gave you that much time because you should be able to solve this one pretty quick. So which of the following values of x is not a solution to the equation above? We see that we have x squared underneath the square root, and we see we have an x over here. So with that, we know that we're going to have our answer be -4. How do we know that right away? Well, we know that because when we square -4, we're going to get 16. Square root of 16 will be 4, but 4 does not equal -4. 4 does not equal -4. Okay, so keep that in mind when you're taking the SAT math section, right? Is that you want to pay close attention to things like that. So our answer there is going to be A, right? You got to understand when things can't equal each other, and oftentimes that's going to be where you have a positive equaling a negative. You can't just use the absolute value. So answer there is going to be A for number 4. All right, let's find another one. All right, let's find another one that I want to do. Okay, so I've already covered numbers 3 and 4. Looking down, we've got numbers 5 and 6. They're paired together. I don't want to solve those ones. Those ones are pretty simple. Number 7, I like this one. Geometry one, we got 2 different triangles. I like it. All right, let's go ahead and do 7. So we have the figure above AD intersects BE at C. If x equals 100, what is the value of y? I'll give you 30 seconds for this one. All right, your 30 seconds is now up, so let's go ahead and go through how to solve this one. Okay, this one right here, not necessarily a whole lot of tricks. I just want to make sure that you're solving this efficiently and properly. So if x equals 100, we got to solve for the value of y. We know to get y, we need to answer for this angle right there. Okay, that angle that I put in black there. All right, so we've got angle x, we know that's going to be 100. So now we have 100 plus 20. We know that's 120. We do 180 minus 120. That's going to leave us with 60 as angle here. We know that these are vertical angles, so we also have a 60-degree angle there. 60 plus 40 is going to give us 100. Then we have 180 then minus that 100 to solve for y. That's going to leave us with 80 equals y. Our answer there will be C for number 7. Okay, this one right here is just a geometry problem, right? Not really any tricks to deal with it, but wanted to show it to you just to make sure that you understood how to do that one, just because it's one that's fairly common dealing with triangles, making sure things add to 180 and things like that. All right, moving on. Okay, we've got question 8. That's just interpretation. We've already covered stuff with that. Number 9, we have a two-way table. We haven't done a two-way table yet today. Let's go ahead and do this one. So on Tuesday, we've got a local gas station had 135 customers. I'll let you read the rest, and I'll give you 30 seconds for this one, starting now. All right, your 30 seconds is now up, so let's go through number 9. So we have on Tuesday, a local gas station had 135 customers. Table above summarizes whether or not customers on Tuesday purchased gas, a beverage, both, or neither. Based on the data, what's the probability that a gas station customer selected at random, that's a key part here, on that day did not purchase gasoline? Okay, so we go to gasoline not purchased. Okay, and we know that we want this out of our total. Okay, so we have 50 people did not purchase gasoline out of our total of 135. Thus, our answer would be 50 out of 135 is the probability that they did not purchase gasoline if they went there. So our answer there is going to be D. Okay, so with two-way tables, the big tip for two-way tables is understanding that you want to draw on your two-way tables. So like I talk a lot about drawing on your graphs, drawing on your two-way tables, annotating your text, right? You really just want to use the passage and the information contained on the test to your advantage, right? So in this case, you obviously go to the right from gasoline not purchased. You see that there were 50 people who didn't purchase gasoline. You see that that's out of 135 people total. Okay, so that one right there, just interpreting a two-way table, but I wanted to cover that since we hadn't yet today. All right, moving on, let's go ahead and find another one that I want to cover. I like number 12. Okay, I like number 12. I'm not going to say why yet. Okay, I'll give the tip after. I'm going to give you 15 seconds to solve this one because it should be pretty quick starting now. Okay, your 15 seconds is up. So I know you're thinking that was probably really quick. Obviously on the SAT, you can take longer than 15 seconds on a problem, so not a big deal if you didn't get it done in that amount of time. But let's go ahead and run through how to solve this one. So we're told that biologists found a new species of pale shrimp at the world's deepest undersea vent, the Baby Vent Field. The vent is 3.1 miles below the sea surface. Approximately how many kilometers below the sea surface is the vent? Okay, in this case, we're given our answer in miles. We got to convert it to kilometers, thus we need miles to cancel. So we have 1 kilometer per 0.6214 miles. Our miles will cancel. We'll be left with our answer in kilometers. We put that in our calculator, and what we're going to end up with is answer choice D. We're going to end up with 5 as our answers. Okay, you could also know this if you know that 5 kilometers is about 3.1 miles. So either way there, you want to make sure you're using canceling units. That's why I chose this one. I chose this one because I want to make sure you understand how to cancel units when dealing with ratios like this. So anytime that you have something like this, some unit conversion at the end of your problem or contained in your problem, make sure that you're looking to cancel units as you go through your steps because it'll prevent you from using the flipped version of the ratio, right? You want to make sure you're using that correct ratio. You do that by canceling units. So that's why I wanted to show this one here. Okay, so what you put in your calculator, there's 3.1 over 0.6214, and you're going to get 5 as your answer. All right, moving on, let's go and find another question that we want to tackle. All right, so let's see here. 13, that's pretty much just one dealing with algebra. Number 11, once again, not really too difficult there. Number 14 and 15. I do like 15. We're going to do 15. Now, as far as if we're going to do 14, let me take a quick look at it. We are going to do 14 as well. Okay, so let's go ahead and cover 14. So I'm going to give you 30 seconds on 14 because it's a bit of a longer problem. So I'll zoom in here, and your time's going to start in 3, 2, 1. Okay, your 30 seconds is now up. So we have a company purchase a machine valued at $120,000. The value of the machine depreciates, which means it loses value by the same amount each year, so that after 10 years, the value will be $30,000. Which of the following equations gives the value v of the machine in dollars t years after it's purchased? For 0 is less than or equal to t is less than or equal to 10. All right, so we know that t is going to be that the number of years. We know that we depreciate by $90,000 since 120,000 minus our 30,000 gives us 90,000 over 10 years. So we go down by $90,000 over 10 years. Okay, so we go ahead and get rid of those zeros. We see that we go down by $9,000 a year. Thus, we can get rid of C, we can get rid of D. Next thing we look at is our starting value. Our starting value at T equals 0 is going to be $120,000. Our answer there is going to be B. Okay, so I wanted to cover this one because it dealt with a slope and over time. Right, I want to make sure you understood depreciation as well. Depreciation means it loses value. Appreciation, right, if it said appreciates, that means it gains value. Okay, so I wanted to make sure you understood the meaning of those words. Depreciates means it loses value. Okay, you can think D as in goes down. Appreciate means that it gains value. You can think A as in adds value. Okay, so that's what you got to understand there, is appreciates versus depreciates. All right, another way that you can know depreciate means goes down is because you see that its final value is less than its initial. So that's another way you could know that as well. All right, moving on. 15 was the next one we wanted to cover. I'm going to go ahead and give you 30 seconds for this one, starting in 3, 2, 1. All right, your 30 seconds is now up. I hope that you solved this one in right around 5 seconds. I'm going to show you why here. We see line M in the xy plane contains the points 2, 4, and 0, 1, which defines an equation of line M. First thing I'm looking at is I see I have point x as 0 and then y as 1. That means my y-intercept's 1. Since I see these are all linear equations, I find the one with plus 1. There's only 1. My answer is D. Okay. I hope you saw that and solved this answer, and solved this question in at least under 10 seconds. Okay, if you didn't and you went through and you solved for the slope or whatever, that's fine, right? It's going to take you probably 15 seconds longer than if you just recognized to solve for this y-intercept. So it's fine if you did that. Just understand that that's an extra step. We always want to look for the least steps possible to get to the correct answer. In this case, we saw our intercepts, right? We saw that our intercept was going to be 1 since we have 0.01. And as soon as you read through this and you get to this 0.01, immediately be thinking, okay, my y-intercept's going to be 1. Okay, that's what you should immediately be thinking since it's going to be a line, right, as you're told right here. So then immediately you should be thinking you should have plus 1. Your answer is going to be D. Okay, so hopefully you got that one really quickly. Hopefully it didn't take you 30 seconds. If it did, it's fine, whatever, as long as you got it correct. But hopefully you did recognize that you can use that trick to find that answer really quickly. That's why I wanted to show that one. All right, moving on, let's go and find another one I want to cover. I like number 17. Let's go ahead and do 17. You'll see why I like it after I go through it. All right, so 17, I'm going to go ahead and give you 30 seconds on this one, starting now. Okay, your 30 seconds is now up. So I'm going to go ahead and show you what I'm looking for in this problem is I see that I've got 2w plus 4t equals 14, 4w plus 5t equals 25, asked to solve for the value of 2w plus 3t. So the first thing I'd be looking to do is add or subtract to get this 2w plus 3t. I see I can't do that since I have 4t and 5t, right, and 2w and 4w. It's never going to work. So the next thing I'm going to look to do is get rid of one variable, solve for the other, and then solve for 2w plus 3t. So I've got 4w here, I've got 2w over here. So I'm going to multiply my 2w plus 4t equals 14, multiply all of that by 2. So I distribute my 2 to 2w, that's going to give me 4w, distribute it to 4t, giving me 8t, and distribute it to 14, giving me 28. At that point, what I'll do is I'll subtract this equation right here, which I'll just go ahead and rewrite it actually. So I've got this 2 times all of this, right? That's going to give me 4w plus 8t equals 28. And then I'm going to subtract my other equation, which is going to be that 4w plus 5t plus 5t equals 25. Okay, I do that. I see 28 minus 25 is going to leave me with 3. My w is going to cancel there, give me 0w. And then I'm going to have 8t minus 5t. I see 3t equals 3. Thus, t is going to equal 1 when I divide each side by 3. Now that I know t is equal to 1, what I'm going to do is I'm going to solve for 2w. Now, am I going to plug in that 1 for t in this equation right here or in this one? Well, I'm going to plug it in that first equation, and here's why. Then I can get 2w right away without solving for w. So I put in this 1 for t. That's going to give me 4 times 1, which I know is just going to be 4. So I'll get rid of that t. Subtract each side by 4. Get rid of my 4 there. That's going to leave me with 10. I have 10 equals 2w. Now that I know that 2w is equal to 10, I have 10 plus 3 times t. I know t is 1. 10 plus 3 is going to give me 13. My answer there will be C. All right, so key things to look for on number 17. First step, if you see you have equations set up like this, the first thing you're going to want to look for is if you can add or subtract the top one or the bottom one in order to get this 2w plus 3t. Once you saw you couldn't do that, at that point you understand you want to get rid of one of the variables, solve for the other, and then go back and solve for this full thing. You saw you had 2w and 4w, right? So you go ahead and multiply that first equation by 2, then you can go ahead and get rid of your w, solve for t, then go back, make sure you plug into the equation that's going to take the least steps, which would be that first one because it has 2w already, and that's pretty much the big tips for that question. That's why I wanted to cover that one, is because it dealt with, even though they weren't stacked equations and the fact that they were lined up right away, we knew that when we had both of those, we'd be looking at it basically the same as a stacked equation set, just we'd have to write it out. Okay, so that's the key things with 17. All right, some other questions I want to cover. Looking at 18 through 20, it's just a bunch of connected questions. And I think we're actually going to do this one. We haven't really done any of those paired questions yet today, so we should probably get at least one in. So let's go ahead and do these ones. I also like these ones because I see I'm probably going to be dealing with canceling units. If not, I'll at least be dealing with unit conversions and dealing with things from a word problem, which I do want to do today. So let's go ahead and do this one. We have Jennifer. Looks like I accidentally scrolled down. Okay, there we go. Jennifer bought a box of crunchy grain cereal. The nutrition facts in the box state the serving size of the cereal is 3/4 of a cup and provides 210 calories, 50 of which are calories from fat. In addition, each of the servings of the cereal provides 180 milligrams of potassium, which is 5% of the daily allowance for adults. If P% of an adult's daily allowance of potassium is provided by X servings of crunchy grain cereal per day, which of the following expresses P in terms of X? All right, so the key thing here is we understand that P is our percent of our daily allowance. We know that we get 5% of our daily allowance per serving, as stated in our word problem right here. I'll go ahead and box it up so you see it right there. So then we know that P is going to equal that 5x. Now, why doesn't it equal 0.5x? Well, first of all, 0.5x isn't even a good wrong answer choice, because we know if it was even dealing with the percent of the total, right, or not even the percent of the total, but if it was dealing with how much out of 1, it would have to be 0.05 anyway. So we already know A is wrong because it's not even a good wrong answer choice. And then C and D, they're both exponential, and we know that we're not dealing with an exponential problem here, right? So C and D are wrong as well. Okay, this one right here answers B. That's going to be the correct answer there. All right, that one right there, pretty simple. Let's go and look at 19. On Tuesday, Jennifer will mix crunchy grain cereal with super grain. Now, we dealt with crunchy grain in this word problem over here. We have super grain provides 240 calories per cup, which we know is more than the 210 that is provided by crunchy grain. If the total number of calories in 1 cup of her mixture is 270, how much super grain cereal is in 1 cup of the mixture? All right, key parts here. We got to understand the serving sizes. Serving size for crunchy grain is 3/4 of a cup. Okay, our serving size for our super grain is 1 full cup. Okay, 1 full cup. So how much super grain is in 1 cup of the mixture? So super grain, once again, will be the one we dealt with in question 19. All right, so we know that our total then in 1 cup is going to be 270 calories in 1 cup. Now, we know that that's made up of some amount of cups from crunchy grain and some from our super grain. Now, the reason I'm going through these and not doing do you see what I see is because it's paired problems and we're going to have to go back and forth, and I'm not going to be able to show all the back and forth on my screen, so that's why I'm going to go through it by myself. All right, so in this case, we've got 270 or 240 calories per cup is how much we're getting from the super grain. So I'm going to represent super grain as S. Okay, so we have 240 calories per cup of super grain. So that's going to be an S there. All right, so that's per cup of super grain. Now, how much do we get per cup of crunchy grain? Well, country grain, we get 210 per 3/4 cups. Okay, so if we want to get how much we get out of 1 full cup, then we have to divide by 0.75. So we'll do 210 over 0.75. So 210 over 0.75, and that's going to give us 280. So we have 240 per cup of super grain plus 280 per cup of crunchy grain, which we'll represent as C, and that has to equal 270. So what we see then is we see that our proportion of crunchy grain, right, and keep in mind that 270, that's going to have to be multiplied by 1, obviously, so we know that that's going to be our C plus S has to equal 1 cup, right, because it's obviously going to be 1 cup on that side. So C plus S has to equal 1. We also have that up there. So what we want to do here is, since we know we have to solve for the amount of super grain cereal in 1 cup, we want to get C out of here. We want to get C out of there, replace it with S. So we know that C is going to equal 1 minus S, because we have to subtract S from each side here to get rid of it. So we're going to have 1 minus S equals C. At that point, we go ahead and plug it in. We have 240S plus 280 times 1 minus S. 1 minus S is equal to 270. Okay, we distribute our 280, so now we have 240S plus 280 minus 280S. Okay, that's going to leave us with negative 40s. Negative 40s is equal to that 270 minus 280 is going to give us negative 10. So now we go ahead and divide each side by negative 40. And that's going to leave us with 1/4. Okay, so our answer there will be 1/4 of a cup, which we see is going to be answer choice B. Now, another way you could have solved this, and I hope you did recognize this, I'm going to quick explain it. When you see that you have this 240s plus 280c equals 270, you should immediately be thinking that 3/4 of your cup is going to have to be that crunchy grain, and 1/4 is going to have to be the super grain, right? And the reason that you should be able to recognize this as soon as you write this in this particular situation is because you see that the difference between that 240 and that 280, right, is obviously 40, and we see that we are 30 towards that 40, okay? So that means we're pulling this up from 240 by that 30, right? We have to add 30 to it. So if you look at the differences, since we have 270 here, I just hope that you can recognize that that means we're going to have 3/4 from the 280 and 1/4 from the 240, right? Because if you did 1/4 times 40, you know that you're going to end up getting 10, right? And you're down 10 from that 280 right there. So I hope you can recognize that sort of ratio and kind of see that it's going to be 1/4. If not, it's perfectly fine. You'll end up solving your answer anyways, right? So if you want to show your work and get all the way here, or if you recognize the ratio, either way is fine. But either way, your answer there is going to end up being B. So that one right there, not too difficult. Just understanding how to solve for it. Also, just one other thing, make sure that you're solving for super grain, right? And not solving for your crunchy grain. So just make sure that you go through and solve for super grain first. Otherwise, you're going to end up taking extra steps. Okay, so you saw that. That's what I did there as well. All right, moving on, last one, 20. Which of the following could be the graph of the number of calories from fat and crunchy grain cereal as a function of the number of 3/4 servings of the cereal? Well, we know that we're going to have to start at 0, so our answer there is going to be A for number 20. How do we know it's going to be A? Well, if we have 0 servings, we're going to have no calories from fat. Okay, so that's how immediately we know it's going to be A. Right, so always be looking for your intercepts and your slopes to find your answer as soon as possible. Right, in this case, obviously, since we know if we don't eat any, we're not going to get any calories from fat, we know that for 20, our answer is going to be A. All right, so that one right there, I went through those ones on my own just because I wasn't going to be able to show all the paired things in my screen really that well. So let's go ahead and move on. Let's find one that I can do the do you see what I see with. All right, one that jumps out to me right away is we haven't done a whole lot with just kind of setting up these equations like 21. So let's go ahead and do 21, exponential functions and things like that. So I'll go ahead and give you about 20 seconds to solve 21, and then I'll go through it. So your 20 seconds starts in 3, 2, 1. All right, your 20 seconds is now up, so let's go ahead and run through this problem, right? So as we read through, we see the graph of the exponential function h in the xy plane where y is equal to h of x has a y-intercept of d, where d is a positive constant. Which of the following could define the function h? All right, well, we know that an exponential function is raised to the power of x. So since we see that option C is raised to the power of 3 and option B isn't raised to the power of anything, we can go ahead and get rid of B and C. So now we're between A and D. The next thing that we know is we know that our y-intercept is D. Now we know that our equation for an exponential function is going to be our y-intercept and then our growth rate, which we could represent as G or whatever, raised to the power of x. Okay, so in this case, we aren't given our growth rate. Our growth rate could, for example, be 3, but either way, we have to have our y-intercept as D, since that's what it tells us. So our only one with our y-intercept as D that is left is going to be answer choice D. Okay, so our answer there is going to be D. We have our y-intercept D. We have our growth rate here, which is going to have to be 3, and then it's raised to the power of x. Keep in mind there could be any number. Instead of this 3, it could be 5, it could be 10, it could be whatever, but it doesn't matter as long as it has that exponential function, which means it's raised to the power of x, with that initial starting value of its y-intercept as D. So our answer there is going to be 3. All right, moving on, let's go ahead and take a look at another problem. All right, we've got 22, looks interesting. Yeah, 22, I like this one. Mean, median, range, standard deviation. We haven't dealt with any of these today. I want to do this one. Okay, the weights in pounds for 15 horses in a stable were reported, and the mean, median, range, and standard deviation for the data were found. The horse with the lowest reported weight was found to actually weigh 10 pounds less than its reported weight. What value remains unchanged if the 4 values are reported using the correct weight? Okay, your standard of deviation, that is going to change because we're going to move further away from our mean, because we'll say that our mean is here, right? We have a bunch of horses that weigh, we'll just say 80 pounds, right? It's probably, horses weigh way more than that. I don't know why I said 80, but let's just say our mean is 80. I'll put mean right there. Okay, we'll say that the least weighing horse weighed 20 pounds, right? Well, now it weighs 10. Okay, so now our deviation from our mean is now increased as we move farther away from this mean. Okay, so standard of deviation, that will change. Now, what's going to remain unchanged? Our range is going to change since we increased the distance from our largest to our smallest, since our smallest went further small. Okay, so range changes, deviation, standard deviation changes. The median will not change. Okay, the reason that the median will not change here is because when we go through our median, we know that we take our smallest and our largest, we get rid of them, and we keep doing that until we get to our middle number. Now, our smallest is still the same horse, and it still gets canceled out, right? So that median is not going to change. That mean will change since we are moving to a smaller value, okay? We'll move to a smaller mean since there is a lower average as we get a smaller horse. All right, so our answer there is going to be B, our median will not change, okay? So I wanted to quick cover that one since we hadn't covered any of those. All right, at this point, I'm going to go ahead and conclude today's video. Hopefully it was helpful. Hopefully you had a good time reviewing. Hopefully you feel comfortable with the math no calculator as well as the math with calculator section. So yeah, make sure to like, share, and subscribe. Have a great day. There'll be a donation link in the description as well if you would like to donate. As always, any private SAT tutoring I'm doing, any private college admissions consulting, private college essay reading, and proofreading I'm doing will be linked in the description as well. Thank you for watching.